Welcome to this video on IP addresses and networking. This is part of the AWS Solution Architect course. A computer somewhere in the world needs to communicate with another computer somewhere else in the world. Usually, computers communicate through the internet. The data is divided into packets by the sender and sent over the internet. These data packets transmitted by the sending computer may pass through several LANs or WANs before reaching the destination computer. Let's understand how data flows from one host to another across the globe. To allow such data transfer, we need a global addressing scheme. This is similar to how the postal department delivers a parcel to your home. Your home has a fixed address and there is no house with the same address anywhere else. This is where IP address comes in. We use the term IP address to mean a logical address in the network layer of the TCP/IP protocol suite. Each host on the internet is assigned a unique IP address so that no two machines on the internet can have the same IP. The IP addresses are 32 bits in length. This gives us maximum of 2 to the power 32 or more than 4 billion addresses. These addresses are referred to as IPv4 or IP version 4 addresses or simply IP addresses. We will not discuss IPv6 addressing scheme here, although the networking algorithm remains the same for them as well. IP address is represented by dotted decimal or binary notation. Now let us see how a data packet reaches its destination on the internet. Let's say you are in Sydney, Australia and chatting to your friend in US using your laptop. The messages you send are divided into packets and sent over the internet. So now, if you can understand how a data packet travels from your laptop, which we call H1, to your friend's laptop, let's call H4, we will understand how networking on the internet works. Host H1 wants to send a data packet to host H4. Now there is no direct path or connection between H1 and H4. But a data packet can reach H4 after going through a number of intermediary hosts, which can be servers or routers. The data packets will always have a source IP address and a destination or target IP address, much like the parcel sent to your home by your friend via post. In the animation, you can see the packets moving in the network from H1 to H4 through H2 and H3 through a series of complex routing decisions made by H2 and H3. Now the obvious question, when the packet comes to H2, how does it know which host to send the packet next? It can send the packet to either H5 or H3. The answer is a routing table. H2 uses a routing table to decide the next hop of the packet. The table tells that all packets with target as H4 should be sent to H3. All the hosts participating in the networking process will have a routing table which will help them decide the next hop for the data packet. Let's look at the structure of a routing table. A routing table will have a mapping for every target IP address and the next hop IP address that the packet needs to be sent to so that it reaches its destination. Now, when H2 receives a packet, it looks for the target IP address and finds the corresponding next hop from the routing table. In this case, it's H3. and not H5. And so the packet is sent to H3. Again, H3 repeats the same steps and looks at the target IP of the packet and finds the right host to route the packet to. In this case, it's H4. This completes the one-way packet movement. Similarly, for the response data packet, the source address is replaced by the target address and vice versa. Now that we understand how a data packet moves on the internet, it's time to move to the next topic, which is subnets. Subnet is an important concept that is widely used in cloud networking as well, and we will create subnets when we do hands-on exercises in AWS Cloud in a later lesson. We will discuss subnets in the upcoming lesson. Thanks for listening. Please like and subscribe to help me continue making educational videos. Till the next time, keep learning.